Okay. So again, please download this link. I posted in the chat that I'm going to show you what it looks like. Now, 1 second. Let me share my screen before I start. Okay, I can kill this part. Okay, here's a web report that this is a directory that you should have. If you untar it. Right, so let me just make a clean and make. You see the program is running. Let me actually first run it in a regular way. If you remember that this is the program that we use to demonstrate the idea about web report between client and server using JSON, RPC, C++. Okay, so if I actually started, let me actually kill this. If I actually started with server, try to run, if I run the server and I run the client, hold on. And then it will say successful, everything is fine, okay? And that's it, okay? Everything is successful and everything is fine because I already run the client, the server over there. So let me actually change a little bit. I want to change this back a little bit so I can show you the difference. So I'm going to put this, modify this to be, sorry, not this one. I'm going to change this to be 0. Okay, I'll change this to be 0 first. Make, to just show you the illustrate difference. Okay, so now I'm going to kill the server. If you try to now connect the client, no, not this one. If you try to connect the client, and it basically, you can see that it will start getting this arrow saying client connector error because it tried to connect the local host, which is the other server, with 8300. It couldn't. And what I did here, I will show you the code. I actually grabbed the exception code. So it's an exception handling, which is, I think I covered that in the lecture 15. It basically captured the exception, but there was information associated with each of the exception to lay out the reason why we actually got this exception. So in this case, exception code is important because we would like to know whether this exception is caused by you cannot connect to the server, or is actually JSON parsing error or something like that. So exception -32003, that's actually given by all the JSON RPC implementation. It is actually the server is not available. Okay, so that's the way that you have to get the server run and before you do that. So now I want to show you how I actually change this code a little bit and such that you will see the result. I will first show you the result and then I will tell you how I actually did this. Okay, so let me actually change this back. Okay, now I'm actually going to run the client again. Okay, you can see that now I'm actually running the client again and I got the same thing, right? Exception, but it will continue to loop. You see that? It's continue to try and try to see, you know, what's going on. And because the server is not ready, if we sit here for forever, it will loop forever and try to wait the server to come up. Okay, so now let's actually bring the server. So now I'm actually bring the server. When I bring the server, you can see something. Okay, now it's keep trying, and then you realize the server is ready. So now it actually finally uploaded correctly and the status is successful. Okay, so that's the kind of simple scenario I demonstrate to you is in general, how you can handle when the client server, when the client is trying to reach the server, but server crashed. And you just basically write a piece of code, go around the code that you originally have and to handle that. Okay, so now I'm going to show you the code and how I did that, which you should already have it over there. Okay, so the code, the rest of the code are pretty much exactly the same as what you originally had for your web report code for homework assignment number 3. I think it's the first time that I actually introduced this code, web report. So what I did is that now I have a flag. I call it unfinished. Unfinished is 1, initially set it up, and then I have a while loop on this unfinished. So essentially, as long as unfinished is true, which is 1, then basically this loop will loop forever. Okay, so inside the loop, you can see that we still have the same structure. We have a try block about my client web report, and we still have this result. However, I add a code here. You can see that here is the difference. I would just say diff, then you know that this part of code is added for supporters. So essentially, I'm saying that if this my client web report is successful. By the way, if my client report raises an exception, it will not even go to the next line. It will immediately go to the catch. So that's why it's a try-catch clause. So whenever you have a try-catch clause, if this particular code is generating an exception, then the code will be interrupted. The control will not move to the next line. It will directly move to this catch clause. So essentially what I'm saying is that if your my client web report is successful without any exception, then you will actually go to this unfinished, the diff over here. I will call it diff 1, okay, diff 01. That's actually going to set the unfinished to 0. Why should I do that? Because now I set unfinished is no longer true. Then whatever next time you go through the loop, it will actually get out of the while loop and then finish the program. Okay, so that's the way how you can actually decide to do this kind of looping to retry the same thing. So now the rest of the magic is really in the catch clause here. The catch clause is essentially from here all the way to here, okay, from here to here, okay, this is the catch clause, okay. So what it does is the catch clause, of course, the original code I have, I print whatever, whenever I have exception, I just print what it is. That's why you will print out those information you saw earlier about the libcurl cannot reach the server. But there is an important thing now I want to teach you is that, well, how do you actually get a code? If you saw the original code, it has this exception. This is, by the way, this line is generated by e.what, okay? This is an exception. What it is a description about that exception. And the important thing is this number. This is called what we call the exception code. And this code refers to the connection error. Okay, that's exactly what we want, because we want to make sure if the server is down, we will actually be able to know that and we will retry that, okay? All right, so that, how do you actually even get that number? The number is using the JSON RPC, the exception, the interface is actually called get code. So essentially you use the E. E, by the way, is an exception object. E.get code, G is capital, C is capital. This will give you the code. I actually add the line that you can fprintf, you can actually print the code. And the code is exactly -32003. So obviously the rest should be pretty simple, that you just actually check if the code is -32003. If it's this code, you just say unfinished still be true, means that I want to be continue waiting for the server. Otherwise, if this is generated by other kind of code, which means other kind of exception, not because the server crash, you just say unfinished is equal to 0 because you know that there's something wrong. You need to take care. It's not just the server issue. And then this will basically make sure that your code will get out of the while loop and basically finish the whole program. There's one more trick I want to tell you is that I actually add this code here. It's called sleep5. Sleep5 is it's a function. If you have a terminal, you can do man3 slip. Okay, man3 slip is basically, so 3 means that, okay, 2 is system call. 3 is what we call library function call. This basically tell you this is a library for you to suspend your execution for a number of seconds that you provide as a parameter. Okay, it's a very useful and in terms of programming that sometimes you want to sleep for a moment and then retry again. Because if you don't sleep, your program just actively running, and that sometimes wastes a lot of the resources. By the way, if you're using, say, services like Amazon Web Server, AWS, it charged by the seconds that the resource you're using from the cloud platform. If you don't sleep, you're going to burn out your credit very, very soon. And one of my colleagues from another university along the East Coast, and he actually got about $20,000 worth of credit. And one of his graduate students is doing something unintentional, intentional. That particular student just burned out 20,000 within a day or something like that. It's just sometimes if you're not careful manage the resources, it's kind of interesting. So just let you know that I usually put a sleep for a few seconds because I know if it's down right now, it's probably not going to be up very soon. And you can decide what is your sleep interval. Okay, you can sleep 5 seconds, 10 seconds, or even 2 seconds, that's fine. Okay, so that's the sleep. And also I just want to tell you, in order for you to get your compiler works correctly, that you need to, this part is already in your code, you need to actually include this line. Because the sleep is a Unix standard library, so you need to have this include UNI std.h. If you don't have that, the linker will actually, the compiler will actually give you an error to prevent you from moving forward. Okay. All right, so that's the part, but I do want to also mention a little bit. You see that I actually print out some message here. One is I said, well, at this time you should reload the post JSON here, and then here you should save the post JSON. I do want to tell you that I provide two facilities to help you to do the JSON to file kind of conversion from one to the other to this to back. So one is called my file to JSON, one is called my JSON to file. They both included in post.cpp. So let me actually just take a look at this code very quickly so you kind of know, because one of the students actually have some trouble today using this one. So this is, okay, not this one. Okay, this one is my file to JSON. So my file to JSON essentially is taking the file name, for example, post underscore A0 whatever dot JSON. That's the file that's actually you save the JSON string. So my file to JSON, you provide two parameters. One is the name of that file, and then you actually have the JSON pointer that you're going to store the converted JSON value object into. So you provide this, and then this function essentially do everything for you. It basically, the first two things it check whether you have a valid name and whether the JV pointer is null. By the way, which means that if you want to use this function, you're responsible to allocate the memory. So you need to allocate the memory, and then you call this function. If you don't allocate the memory, that say you provide a null pointer, the function will detect it as a null, it will immediately return the error. And it won't do anything, do the conversion, just to let you know, because sometimes you forgot to do that, and then later you cause a segmentation fault. That's very common happen. Okay, so that's the interface, my file to JSON. And similarly, there is my JSON to file. Okay, my JSON to file is exactly the same interface. Also, the first one's a name. The second one is a pointer, but it's the other way around. Means that it actually pull out the JSON value object and save it to the file name that you provided here. So it's the other way around. You can see that I'm open this as a writable. It's writable, I'm going to write it into that. So essentially what I did is I just generate true style string and put it there. You can actually take a look at the code. You should be somewhat familiar with the code because starting homework maybe 3, 4, 5, you saw segment of code. So essentially what I'm doing is I'm just putting that code into a function interface, like on my JSON to file, my file to JSON, because we use this a lot, especially for homework assignment number 6. And so this is very handy for you to use those as a facility. And I do want to clarify for, don't use anything from JSON post.cpp. I should have deleted because that was a really old version and a lot of code has been revised. It will not be compatible, okay, with the rest of the code. So you should use all the code just from post.cpp, which has all this interface. All right, so that's my demonstration about how you can actually build that robustness into your client server, such that your client will be able to periodically, constantly try whether the server is available. Okay, all right. Any question for this part of homework, homework 6, part 2 specifically? Okay, no question. So I'm going to stop recording.